Hi there once again and welcome to another Expresso mechanic tutorial. And in this one we're going to be taking a look at a node that we've never seen before, which is the Colour Vertex Node. Quite a useful node actually, and quite powerful, and you'll see how this works. I mean, you can see what we're doing on the screen, and this is what we're actually going to be creating in order to illustrate how this thing actually can be used. But it's going to be quite an interesting journey, I think, and we will also be using a little bit of Python in this as well. So there's a few different things that we're going to be looking into. But anyway, that's what we're going to be about in this tutorial. So without further ado, let's see if we can make this happen. I'm going to bring in a plane. And initially, I'm just going to make this thing 20 by 120. And I'll give it 6 width segments and probably a single height segment. Let's just make sure I've done that correctly. No, other way round. 1 width segment and 6 height segments. Okay, we'll just hit O to take a look at the object. Right, so we've got this here. Now, if we make it editable, we'll just hit C. What we can then do is come into our tags here, other tags, and we'll bring in a vertex color tag because this is going to be important. We can then select points. Now, we've got our paint tool here, which is now selected, and I can select certain points and start painting on them. But what I'm going to do is just select a color first. So if I just make this totally red, you can see now that I've painted a color on this particular vertex. It's now red. This point is red. If I do the same over here, I've colored those two. Now, if I just make our color green, paint here and here, we can see that we're getting a blend through here because we've got 2 red points and we've got 2 green points. And we can keep on doing this. If I go yellow and yellow, we've now done this here. And we've created a similar situation. We can see that we're blending between the yellow and the green. So you can see the way this works. Now, it's quite powerful because if we come into our textures here, just double click to create a texture, open this up, and in our color here, if we say texture, come down to effects and we select vertex map, we can then drag this into here, place the texture on the plane, and then if we hit render, it will actually render what we've done. So quite a powerful tag and quite useful. Now there's some extra functionality that we can also illustrate. If we just reselect the tag here, in this vertex colors we've got points only, which is the mode that we're using at the moment. You can see that we are painting the points only. Now we can say polygon points, and that gives us different result. So if we, with our paint tool now, if we go into our paint tool, we can say apply selected. Now what we need to do first, if we select some points just with our brush selection, if we just select these 4 points, go back into our brush, our paint tool, and we can then say, if we just change the color, let's change it to a blue. Just take that down there, just change that to a blue. And if we say apply selected, we can now see that we've covered the entire polygon. And if we just render that out, we should get a different result. And as you can see, we've got no blend between these two because we've painted the entire polygon. So that's an option that you actually have within this tag. And we can see that the tag has actually physically changed. We've got squares in there now where we used to have circles. So it does actually tell you what mode it's in. If we go back to points only, we can see that they've changed back to circles. You know, so there is a change, and it does make a difference to how this actually works. But anyway, that's the tag explained. So you can see that that's quite versatile and it does have its uses. Let's now think about where we could go by using Expresso with this. What we'll do, I'm just going to lose this plane and I'll create another one. So let's just bring a new one in and we'll set the orientation to +Z. And if we just swing this round, zoom out a little bit so that we can see what we're doing. We're going to make the plane a little bit different to this anyway. The sizes we're actually going to change. We'll make it 100 by 100. And in the segments, we'll just make it 2 in the width, 2 in the height. And we've got a new plane hiddo so that we can see that and just frame it up. Okay, fantastic. So we've got a new plane object that we can now work with, and then we can think about doing some Expresso. So we'll bring in a plane, call it Expresso. Apply the Expresso tag. We've got the window open. And we're ready to start work. The first thing I'm actually going to do is sort the plane out. So we'll make it editable for a start, and then we need to add our vertex color tag because we're going to need that in the Expresso expression. So we can drag that in actually. Just bring that in here. So we've got the node for that, and we can just give it an object output port. Okay. We now need our vertex color. So let's see if we can find that within our Expresso expression nodes. We've got, here we go, our vertex color down here. It's in the general menu. So bring that in there. And it's got a yellow top because we need to just connect the tag. So we've got that connected there. So we can see that we've got currently 2 ports at the input stage and 2 at the output stage. We can add ports at the input stage, and we do need to add a color port. And we've got an index. Now the index relates to the vertices, so they're point indexes basically. And we can actually take the count value out of here at the output stage, and if we just do that and connect a result node, we can see what we're doing there. So we've got 9 because we have 1, 2, 3, 4, 5, 6, 7, 8, 9 points. So that makes perfect sense. So that's basically what we need for our vertex color node. It's set up as it needs to be. Now this index, obviously we can look at various different points by using their index values. That allows us to do that. And by passing a color vector into here, we can change their colors. Now, the most important point to make here is that we cannot do the polygon points thing that we did earlier using Expresso. That's one restriction of this. You can't do that. You can only use individual points. So you're still going to get this blend between colors. You cannot have solid colors in there. Unfortunately, it's just one of the limitations of this. It'd be great if they can sort that out at some point in the future, but at the moment, that's the limitation that you've got. It is a shame because it makes this slightly less versatile than it would be if that was available to us. And, you know, it's just one of those things though. So that's it. That's your vertex color node. And we've got our tag plumbed into it. So moving on from here, then we can think about what we're going to do next. This is actually going to be the final part of the expression. So we'll move this over here. Now to begin with, I'm going to bring in a time node. As per usual, remove the time port and put a frame port there. So let's just do that. And we've got our time node set up. Now what I'm going to do with this is what you saw earlier on. I'm basically going to choose a color for a vertex. In fact, what I'm going to be doing using Python, I'm going to randomly choose one of the vertices and then give it a random color so that we don't get the same thing every time we run the sequence. It's just for fun, and it just goes to show you what can be done with this. So moving on from our time node then, let's bring in the first of the nodes that we're going to use to actually get this to where it needs to be. So we'll bring in a math node, connect the frame output to input number 1, and in our function here, we'll change this to modulo, and we'll say modulo 30, because we want a color and an index value to be chosen every 30 frames, so once per second. We now need 2 compares, so we'll bring those in. Let's bring in the first one and then we can simply command drag to copy the second. Again, our frame port can be connected to the input ones of both of these compares, and then we can decide what we're going to do with them. The top one here, we're going to change the function to greater than or equal to, and it will be 30. Let's just set that up, 30. This one does need to be equal to 0, and you'll see why very shortly. Moving on from here, we need a bool. So we'll bring one of those in. Its function will be AND, so we don't have to change anything there, and we just need to connect the output of the modulo to input 1 and the output of the compare to input 2. So when both of these conditions are true, this will be true, and that's what we need to use for our next step, because this is going to be the trigger for a monoflop. So we'll bring the monoflop in, and then we can set this thing up. Now we need to add a reset at the beginning, or rather at the input stage, and we need to add a count at the output stage, because we're going to be using this purely as a counter. So when these two are satisfied, we want to trigger our monoflop. So we need to plumb this into here, and we also need to change the monoflop from a normal to a one shot, because obviously we're going to get a 1 here, so it will be triggered when we get a 1 as opposed to a 0. The reset will be controlled by this, so when we're at the beginning of the animation, we want to reset our counter. That's what we're doing. Okay, so that's our monoflop taken care of. Moving on from here, we come to the all-important node, which will be the Python node. And we can then think about setting this thing up. At the input stage and output stage, we'll remove all of our ports because none of them are any good to us, and we can start from scratch. The first thing we need will be an integer, which will be a frame port, and we need a second port, which will also be an integer. So we'll rename this one frame, and this one we will rename index. Our frame port we can connect from here. We'll just bring that in here. Just move these down a little bit so that we can see what we're doing. And the count value here will be the index. So that's taken care of the input stage of our Python node. The next thing we need to do is set up our outputs. Again, we'll bring in an integer, rename it, and this will be called point on this occasion, because it basically is going to be an index value, but we can't use the index at the input stage and the output stage, so we've got to give it a different name. So we'll call this one point. We then need the values that we're going to use to create a color vector, so we'll bring those in. We need 3 floats, and they will be renamed once we get those in. Let's just bring them in. Just double click on that to make it a little bigger with the command key held down, and we'll rename these. Now these are going to be R, G, and can you guess what the third one's going to be? Yeah, B. RGB. And that's fine. We've got it all set up and we're ready for the next step, which will be to start coding. So what we'll do, just close this up for a second, switch to a scripting layout and open up again, select the Python node, bring this up, and we're ready to start work. Just resize a little bit here, just we don't need the window quite so big. Okay, great. So we're ready to start, and we can come up to the top here and just say import random, because we're going to be using random values, so we need to import the random module. We can remove this line here, we don't need it, so we'll get rid of that. And then we can think about putting some global values in here, some global variables. So we'll do R, G, B. If we just open this up, we can see that we've dealt with the outputs here those now, so we've got all of these in. We'll just put a comma there. So they're all taken care of. And now we can think about working with a few others. We just need a couple more variables, and they will be points and numbers. And you'll see what these do a little bit later. There's not actually very much code to actually do here, but we'll carry on. So we can say if frame is equal to 0. So when we're at the beginning of our animation, we want to do something, and that will be to create two lists, and they will be numbers and points. So numbers is equal to an empty list, and also points equal to an empty list. That's all we need to define with regards to doing these two here. We just got to set those up. We can then start working with a couple of while loops. So we can say while, if we spell it correctly, while len brackets numbers is less than 9. So while our list here has less than 9 values in it, we want to place values within it basically, and they're going to be random index points. As I said, I wanted to create random index values and random colors. So that's what we're about here. So we can say random, or RND for random, is equal to random dot rand int, because we want integers because they're index values, 0,8. And we know that we're going to add points are always valued from 0, and they, in this case, through to 8. So that's why we're using these values. If RND is not in numbers, numbers dot append RND. So all the time we're selecting a value that's not been placed in here, we can add this to here, or append the list with that number. That's how this is going to work. So if we choose the same number twice, it won't be added. And it will, while the while loop isn't satisfied, we'll keep on doing this. So that's our first while taken care of, and that will populate our numbers list. We now need to simply repeat the process with our points. So let's just copy this code and paste it in here. Change numbers for points. In all 3 places. And I've just realised I should have put an S on numbers there. Okay, so that's all correct. All set up and ready to go. And that will populate both of these lists. And what we can do, in fact, we've got an error there. I need to just bring that back to the correct level. That's better. That should be there. Right, okay, let's double check to see if this is working. If we say print numbers, print points, move this out of the way, just clear this out, execute, and let's see if we get anything. Do we get anything? Are we at 0? Yes, we are. Let's just make sure. Let's just move these back to there and execute. Oh, not getting anything. Why not? I know why not. Because we've got nothing connected to the output stages, and we need outputs. So if we just connect, try connecting a result node and see if that makes a difference. We might need to do all of them. Aha, it does make a difference. We've still got an error because we've got no value for the point, but that doesn't matter. But you can see that we've got our lists. So it is working. It's definitely creating 2 random lists, and they've each got 9 numbers in them. So that's actually working fine. So yeah, I'm not worried about that error. That doesn't matter. Doesn't mean anything. So let's just take that away and take that away. Fantastic. Right, and the next thing we need to do, if we've already got colours assigned to each of these, we basically want to erase them. We want to take them away and make the thing blank again. The way we do that is to say if frame is less than or equal to 8. So we're going to do this over the first 9 frames because obviously our frames start at 0. So we're going to sequence through the first 9 frames, and every frame we're going to take away the colour from our vertices. So we can say point. So whatever's, this is what's coming out of here. So point is going to be equal to, and it will be points brackets frame. Okay, so our frames are going to allow us to sequence through this list of points. And we can then say R is equal to 0, G is equal to 0, and finally B is equal to 0. And that will clear them out. That will send 3 zeros to R, G and B. So that's fine. That's going to work exactly as it needs to. The next step, we can say else. And now I'm going to define 3 tuples, one for the red, one for the green, and one for the blue. So if I say red is equal to 1, comma, and it will be 0, comma, 0, comma, 1, comma, 0, comma, 1, comma, 1, comma, 0.5, comma, 0.5. I should have 9 values. 1, 2, 3, 4. Yep, I've got 9 values. Same for the green. So green, not green is equal to, and it will be 0, comma, 1, comma, 0, comma, 1, comma, 1, comma, 0, comma, 0.5, comma, 1, comma, 0.5. And then finally blue, and that will be equals 0, comma, 0, comma, 1, comma, 0, comma, 1, comma, 1, comma, 0.5, comma, 0.5, comma, 1. So there are our 3 tuples, and we can see that the first one, if we go down them, we can see we've got 1, 0, 0. So that's going to give us a red. The second one is going to give us a green because it's 0, 1, 0. And then our third will be 0, 0, 1, which will give us blue, and then etc. So I've defined basically 9 colours that we can actually sample from. You don't have to do it this way. If you wished, you could define 3 more lists, R, G and B, and then you could create 3 more while loops and generate random numbers between 0 and 1 and fill the lists with those values, and then pass those values to the outputs from the Python node if you wished. But I've just decided to create a palette of 9 colours based upon the values stored in the tuples. Okay, so we've got those set up. We can now think about moving on from here and say point is equal to, and it will be points, square brackets, index. Because we know that we chose our point values for our randomly chosen index values, and that will enable us to output whichever colour is coming out of here or it's been generated here, and it will be passed very shortly to the RGB values we can then assign to the given point. So finally then, to finish this off, we simply need to say R is equal to, and it will be red, square brackets, numbers, square brackets, index, double close. We can then copy this code and say G is equal to, and it will be green, and finally blue. So paste in again, blue, or B is equal to blue, numbers, brackets, index. And that is the code complete. That's as much as we need to do. Okay. So let's think about where we need to go next to actually finish off this Expresso expression. Well, if we just bring these a little bit closer, the only node that we need now is basically a reals to vector. So we can bring one of those in, go into our adapters here, reals to vector, and we can plumb each of these into the X, Y, and Z ports at the input stage, and then the output can simply be plumbed into here. Now, we're getting the reds, or rather the yellow tops, because we haven't done the index value yet. Now, the index value, again, that simply comes from the point value here. Just plumb that into there. Okay, so that's looking reasonably good. Now, let's just see where we are here. We may still have an error. I'm just going to just check. I think I've got a syntax error in the green by the looks of it. Yeah, I've got a comma that I need to place there. I think that's probably what's causing that. Yes, it is, because we can see the yellow tops have all gone now. So there's just that little syntax error there. Okay, great. So that is looking good. We've got a point after that one as well, which I don't need there. Great, that's fine. That all looks good. Right, fantastic. So let's just see what's happening now, and we'll see if this actually works. So let's just clear this out. We'll just run the sequence, just select the tag there, and let's just run this. Right, okay, so we've got int object is not subscriptable. We've still got an error. So line 42, let's have a look, see what we've got. It's got to be points. There was a syntax error there, so I didn't put the S on the word points. Let's see what happens now. Let's have a look. Points is not defined. It won't be because we're not back at 0. Now we come back to 0. Let's see what happens now. Aha! And we're getting colours. Now we haven't got enough frames, so we need to give ourselves 200 frames. Possibly a few more. Actually, I'll go 300 just for what it is, just to make sure that we've got enough. Let's just play this. There we go. And we're now getting randomly chosen colours assigned to randomly chosen points. Right, we've got a list index out of range at 42. Let's see how we are here. Probably because I've got too many frames. I think that's what the problem is there. Let's just take the frames back to, say, 270. You've got to make sure you've got the right number of frames, otherwise you will get that error, unless you trap it. But we'll just, you can see where it cleared it out there. That was all working over the first 9 frames. So that's done that. See where we go from here. And there you go. You just need 270 frames and everything's fine. But yeah. And you can see that it's working fine. And once again, we can, if we get our texture, let's have a look, see we've got our texture, drop this onto our plane. If we open it up, open our vertex map, drop this into here. Okay, so we've got that in. Let's just carry on playing, see what we get. Right, we've got it all there, and let's just render this out. And you can see there it is. So yeah, I mean, this is, as I say, quite a versatile tag and quite a versatile node, this vertex color node. You know, it allows you to actually create like programmable textures effectively. I mean, this is very simple stuff. You could do much more complex stuff with this, I'm sure. For example, if you had a plane that was more subdivided, it would be possible to write your signature into that particular object. You know, something like that would take more programming, obviously, but it's perfectly feasible to do it. Have a think and see what ideas you can come up with for making use of this particular setup or something similar to it. It can be very versatile. But yeah, I mean, I quite enjoyed playing around with this. I found it quite fascinating, actually. And it's, yeah, it actually does work in quite an interesting way. And it's just another way of sort of texturing an object, really. But yeah, I mean, that's essentially the end of the tutorial, because that's what I wanted to show you in this one. So quite a simple expression, really, and you know, nothing much to it. I mean, the Python is probably the most involved part of it, but as I said, there's not a great deal of code here, just a couple of while loops, some just global variables, a couple of while loops, a sequence to clear the texture out and make it blank again, and then a sequence to work with the randomly chosen colors and also the randomly chosen index points, and assigning those colors to those randomly chosen indexes to give the points their random colors. You know, that's all it is. It's not a particularly complex expression. And as I said, you could create 2 more or 3 more while loops and generate random values to be placed in some more lists, and create a situation where you could have any color assigned to any of these. So, you know, maybe might be worth having a little experiment with that. You know, I think it's random uniform that you use in there, just random uniform. But you know, don't take my word for it off the top of my head. Double check that out for yourself. But you need to generate a value between 0 and 1, and then pass that to the RGB outputs here. And yeah, it does require a few more lines of code, but it might be quite a fun little experiment to try and see if you can make it actually happen. But anyway, that about brings us to the end of this tutorial. So as always, I really hope you've enjoyed doing this one and that it's inspired you and given you some ideas for a few things you might be able to use within your own projects. And if you have enjoyed the video, then please give it a like. And if you haven't already, please subscribe to the channel, leave a comment, and of course, ring the bell. And wherever you happen to be on social media, please do share this video, because all this good stuff really does help keep the channel moving in the right direction. But anyway, that about brings the curtain down on this one. So I'll see you very soon on the next tutorial.